All right, so welcome back, students. Let's look at if you are following, we are doing matrix, right, and linear transformation. Now, on a previous episode, we did multiplication of matrix, right, 2 by 2 matrix, and a multiplication of what? A matrix, a 2 by 2 matrix, and then a column matrix, right, or a vector. Today, we are looking at equality of matrix, okay? Now, when we say equality of matrix, it's very simple. Everybody, you understand the term equal. Equal means the left-hand side of the equation. Normally, when we say equality, we are introducing an equation in which the left-hand side, the component of the left-hand side is equal to the component at what? The right-hand side. So, in short, if I have a matrix A, which is A, B, C, D, and I have another matrix B, which is equal to X, Y, W, Z, and I told you, if I tell you A is equal to B, then what it means is that the coordinate of A, B, C, D, is equal to the coordinates of B, that is X, Y, W, and what? Z. So the coordinate of A is equal to the coordinate of what? B, right? Now, which further means that A is equal to X. Look, the first one is always equal to the first one. And then I can also see the second one is equal to the second one. I can also say the third one is equal to the third one. And I can also say the fourth one is equal to what? The fourth one. Now, we usually use this equality of matrix, this one, to solve variables when we have questions containing variables. For instance, if I have A, equals 2, 4, minus 2x, 3y, okay? And if I have the matrix B equals 4, 7, then I have minus 24, and then I have 12. If I tell you to find the value, find the value of x and y, you simply use equality of matrix. Now, find the value of x and y if A is equal to B, if only A is equal to B. Now, if A is equal to B, what it means is that the coordinate of A, 2, 4, minus 2x, and then 3y, is equal to the coordinate of B, that is 4, 7, minus 24, and then 12. Now, which further means that this one doesn't really interest me, because that's not where this I want. This I find x and y. So I come to the x column. If I check this x column, it's equivalent to what? This. That's negative 24, right? And this one is 2x, which means that my 2x is equal to what? Negative 24. So I can easily find x by dividing here by neg 2, dividing here by neg 2. This cancels that. So here my x is going to be what? 12, okay? And then, looking at the y corresponds to what? 12. So I can say 3y equals what? 12. If I divide here by 3 and divide here by 3, it means y is going to give me what? 4. Because 12 divided by 3 is what? 4. Are you okay? So let's solve a question like this, right? So for instance, if I have a vector A, if A equals 3m for 2 and 7, and I have B equals 4, 3, 2, 1, then, okay, if I tell you to find M and N if, let's say, A equals 3B, right? A equals 3B, and then 2A plus B equals 2B, something like this, okay? So let's look at the I. The I says A equals 3B, which means that if A equals 3B, we have the coordinate of A, 3m for 2 and 7 equals 3B. Now, 3 times the values of B, that is 2, right? This is B. Simplifying this one, I have 3, there's nothing to simplify here actually, so I keep maintaining like that. This is what I have to simplify. So this one becomes 12, 3, 4, 12, 3, 3, 9. This one is what? 6, and 3, 1, 3. Remember, this is multiplication of a matrix by a scalar. Now, since they are telling me that A equals 3B, then I can say that 3M equals what? 12, right? 3M equals 12 because the first is equal to the first. Now, if I divide here by 3 and divide here by 3, my M is going to give me what? 4. Are you okay? My M is going to give me 4. And then, since I want N, I can say 2N equals what? 6. Do you see that? 2N equals 6. If I divide here by 2 and divide here by 2, my N is going to give me 3. I'm done. Okay? Now, let's look at the next one. The next one, they want 2A plus B equals 2B, right? So they want 2A, so that's II, which means that I have 2 times the coordinates of A. The coordinates of A, I have 3M, I have 4, I have 2N, and then 7, plus the coordinates of B, which is 4, 3, 2, 1. They say equals 2B, so 2 times the coordinates of B. 4, 3, 2, 1. Now, let's simplify. This is going to give me, this time this is going to give me 6M. And then this is going to give me 8, right? This is going to give me 4N. And then this is going to give me what? 14. Is that not so? 14, right? Plus, of course, there's nothing to do here, so let me just keep it like that. This is where I have to simplify. 4 times 2 is going to give me 8. 4, 3 is going to give me 12. 2, 3 is going to give me 6. 2, 2 is going to give me 4. Then 2 times 1 is going to give me 2, right? Let me simplify this. So 6M plus 4 is going to give me 6M plus 4. Please, it's not 10M. They are not the same, okay? Make sure you don't do that mistake. It's not 10M. It's 6M plus 4. Now, 8 plus 3 is going to give me 11. Now, 4N plus 2 is going to give me, of course, 4N plus 2. They are not the same, so you cannot join them, okay? It's going to give me 4N plus 2. And then 14 plus 1, of course, is going to give me what? 15. Then this is going to give me what? 8, 6, 4, 2. Now that I've finished simplifying them, they said I should find the value of M and N. Since this is where my M is located, I can say 6M plus 4 is going to give me what? 8. Okay? So it means that here my 6M is going to give me 8 minus 4. So my 6M is going to give me what? 4. If I divide here by 6 and divide here by 6, my M is going to give me what? 4 on what? 6, which is equivalent to 2 on 3. Okay? And then if I want my N, you can say that 4N plus 2, this side is equivalent to 4, equals what? 4. Is that not so? So I have 4N equals 4 minus 2. So I have 4N is going to give me what? 2. If I divide here by 4 and divide here by 4, this cancels this. N is going to give me 2 on 4, which is equivalent to 1 on 2. Are you okay? So this is how we find equality of matrix. So on the next episode, you'll be giving more questions to solve here. On the next episode, we are going to look at how to find determinant of 2 by 2 matrix and determinant of 3 by 3 matrix. Thank you.